wastewater treatment plant, it depends upon the type of industry existing in that area. We also saw there are two scenarios city can do, whether it is delegated or directly managed by the administration. In one scenario, you say the domestic wastewater from the residents is treated and discharged depending upon the location where they want to discharge, right? Another scenario, you have a lot of industry, it is just not possible to accommodate with a municipal sewage treatment plant. So that is why we construct different specifically for to treat industrial wastewater. We have also seen how the scenario is here. You might have seen this is a common effluent treatment plant where all the industries are located. They collect the wastewater, then they send it to common effluent treatment. But we also saw what are the issues with the small and medium industries. They cannot afford to have a big treatment plant. There are many issues. That is why when you make a regulations, when you make a planning, you should also understand on other side, right? If they are not connected to the sewer system, if the sewer system is not capable of that, if the sewer system doesn't exist where they can discharge, if their discharge is not continuous, if their discharge is intermittent, if their discharge is seasonal, like you will have to be taken all these factors to be into consideration, then you design. That's why each city town design of treatment plant is different. I said the limits are developed in the local limit. How they are developed, it not only depends on the standards of the state. That's why we give a little leeway for the cities town based on the existing industries, the scenario they can design. And local limits are developed accordingly. How they are developed, it is not reference to the city, even though we say city is local limit. But these limits are developed based on the treatment plant capability, correct? That is, but we say that these are the city limit. That is just a kind of understanding. Then we also saw what are the scenario. We have to treat the wastewater coming from the industries. That is there. In addition to that, it also developed the sludge. We talked much about how to dispose of the sludge. What are the issues with sludge? What are the contaminants in the sludge? How the sludge can be converted into manure? How, in what circumstances that cannot be used as a manure? And how you will remove thickener and other various components. We saw that. So that was all. But today we will see it is the importance of taking care of the wastewater when there is a presence of metal. Right? Then we will go for biological treatments. So here if you see the national pre-treatment program or any program, pre-treatment program which is applied to any location or statewide or the national pre-treatment program, a component of the NPDES permit is regulatory program established under the Clean Water Act. So it started with the Clean Water Act. This is the model which they developed for the nation. Then it is applied to different states, different cities, town accordingly. So that is the treatment work which is owned by state, municipality, or includes the devices system used in the storage, treatment, recycling, reclamation of either sewage or industrial wastewater. Liquid in nature. There may be domestic wastewater, it may be non-domestic. That's why we call to make it more precise as a non-domestic, right? So any non-domestic will go. Sometimes they say we produce the wastewater similar to the domestic wastewater. So that's why we make domestic wastewater, which is coming from the residents. Then rest is non-domestic and the industrial. Right? What is the difference between the domestic and the industrial wastewater? It has high BOD, it may have high suspended solids, it may have other pollutants of concern also. You have seen various scenarios. We also saw two case studies yesterday. Why I gave those two case studies? You also seen a couple of videos where I work very closely with them. So in that case studies, we wanted to make it more clear what we do, what the planning is done for the national level to the local level, how it is implemented. So that is why you do survey what kind of industries are there, and you scan thoroughly how the each industry is analyzed and then discharged, so that it cannot have an interference with the receiving treatment plant and also cause cost. So that is the very intent. So if you say the treatment plant in the sense, it is not only the treatment plant, it is the treatment plant, sewer system, manholes, pumping station. There are various components that you know. It all works as a one, not independently. They are all connected, are designed primarily, that is the wastewater treatment plants in the city is primarily designed for domestic wastewater, not to treat should make it acceptable to the receiving plant, right? Then oversee designed to treat primarily domestic wastewater, not toxic and non-conventional pollutants. That we have to always keep in mind. Your first job as an administrator, tomorrow you will become a plant manager or a city authority. Your first job is to protect. That is why I always emphasize you have to do your job correctly. Otherwise, it will cause severe issues everywhere. Right? Toxic pollutants can affect the efficiency of microbial process at POTW, reducing the treatment capability. Right? Gases and vapors from the volatile organic can accumulate in the head space of the sewers. That you have seen the example. If they are just discharging like that, if they are discharging oil and gas, so there will be always vapors depending upon type of pollutants, gases. It may just cause an explosion in the sewer line, right? So that is why you have to make sure that the receiving all the industries which discharge wastewater to the city, they have taken sufficient care. That is why you give authorization. That is the privilege. You will say you will accept the wastewater, but under following conditions. So that is how you do that, how you confirm. You do sampling, you do analysis, you find out the data. Is it? Based on that, you will do an agreement. This is what we can do for it, right? Then we have some emphasis on the clean water when it has come up into regulation and what it consists of. Primary federal law and regulates the water pollution, restoring and maintaining the quality of the national water bodies, preventing, reducing, eliminating water pollution, establishing condition discharge pollutant into waters, developing toxic pollutant list, and contains 65 entries deemed to be toxic, and we also developed a derivatives list form titled priority pollutant. I spoke a little bit about priority pollutant also yesterday, right? Then published analytical testing methods to them to be used by manufacturers in determining the presence of chemical and their toxicity. What it does, if we have a law then only you can apply. Then only you can prevent the discharges, right? You can find the importance. So if you want to take any action, you need a clause under what circumstances you can take an action on the violations. You just cannot decide on your own. So that is why this Clean Water Act plays a very important role in the, not only in the US, it is in the whole world. Many countries started following, understand, but somebody should step forward. So they spent a lot of resources and developed a system. So that is what you are trying to understand how it, and they are already modified. There are regulations and rules here. Pollution boards are established. We have a municipal rules. Only that has to be applied precisely. So then regulations about that gives list of toxic. If I say toxic pollutants, there should be some list, right? You need some guidelines, need a manual, is it? And what are the rules, where it can be applied, how it can be implemented, all that has been put into that, is it? So definitions, interference, pass through, and what are the other pollutants? There are three major categories: metals, pesticides, volatile and non-volatile organics, right? What are the common toxic metals which can cause detrimental and harmful effect both to environment and human health, right? We talked about some of the contaminants, metals. Yeah, one of your colleague was talking about chromium. Couple people are working on the chromium. See, if that is present in the wastewater, if it is not taken care of, that what will happen? It will start destroying the whole system what has been built. That is why it is very important. So I want to go a little step back. Earlier what used to happen is, you might have people give an example. We used to drink river water. So you might have also heard about the stream purification. It has, what treatment you are doing here, it is all existing in the nature. We have sedimentation tank there, we have aeration. When the depth decreases, it becomes an aeration there. When there is a big deep pond like terrain, it acts as a settling tank. Everything is there, is it? That is how it used to happen. Even little contaminant was there that time. There were not treatment plant. There was a domestic wastewater only. They used to treat itself, right? BOD, aeration. Then in the morning sun, then ultraviolet. It's kind of a disinfection. That is why there was not much contaminants. But it has a capacity. If you are discharging about 100. I used to teach environmental for many years. So the self-purification of stream, all of you may be knowing, many are teaching in that. So it has a limit. If the BOD is 100, it can take care. If it is 1000, if it is 5000, 2000, industrial waste, you might have seen. I think people who have worked in the coal mine and leather industry, you know what is the quantum of BOD, right? How you will analyze that BOD first. You do a BOD analysis, you do COD analysis. First you want to find out in the industry whether it is biodegradable or not. If it is not a biodegradable, if you are discharging, what will happen? It will not biodegrade. Is it? And many of the pollutants are man-made pollutants. Earlier these things were not there. That's why these contaminants were not there. Today we have everything, right? Fiber, plastic, everything, many things. So there are man-made pollutants, right? So that is why these we made them, and then we should also take care of that, right? So that is why these are the different contaminants today emerge in the current situation. Arsenic, beryllium, cadmium, chromium, copper, they depends upon the type of industry. Accordingly, they will be entering the wastewater stream. Detection using atomic absorption spectroscopy. Yeah, we have given a little bit about how these metals are analyzed, how what are the equipments used in the system. Gas chromatography, I have used this gas chromatography for many years. If the concentration is small, most of them are doing PhD, masters, right? You might have used this kind of an equipment. So these are the equipments which are widely used in the analysis. And also you have a guidance document which is developed uh, standard methods, okay? Standard methods. And now there are pollutants we do not know how to analyze them. Those are not there in the standard methods. Still, we are trying to find out which must be the appropriate method to analyze. Hazardous level, toxicity of the metal, and their effect on human environment. So I have told you, I have one slide where you can see what is the effect, what happens, right? So you can see the effect of these metals if they are entering into the environment, if we are entering into our ecosystem, what are the side effects here, right? So you know about arsenic, somebody was talking about the arsenic also, right? Arsenic hazardous level, antimony hazardous level is given, health effects, you can see. We're all inviting these kind of health effects. So unless you fix it, how much medical infrastructure you want to develop, keeping these, right? That is why the role of people who are involved in the environmental field has a lot of responsibility. People are getting attention, more attention. That is why wherever you have opportunity, you should be able to speak, make the people aware, implement the regulations, educate the people, understand the latest technologies which are existing or developing so that you can implement. See, yesterday we were talking about a case study. There was an industry which was using a old method. That's it. Was able to identify what's wrong. But they were doing the things for many years. You can observe that. So I found that this is not wrong. This is not the way it has to be done. It has to be done differently. If you take a step forward, then only you can do that. Otherwise, that will just go like that. See, reducing from 600 milligram per liter to 500, you can see big achievement. If you don't take action, if you don't involve and try to find solutions, then things will just go like that. That's why, however, we have the capability, your contribution and creation is very important. I have had a conversation with many people. They are so much interested in the subject, so that is very important. You should have a passion to do something. So that is how I was specifically giving those examples. If you step forward, you can fix the things. There may be failures, there may be some issues, it may delay, there may be consequences, but ultimately Ultimate result is important, right? Somebody has to do step forward. So that is why they removed the old system. They put the advanced system, right? If you know the system well, then people can work out of it. That's why you should always keep updating yourself. I'm very happy that a lot of people are participating in this such conferences, so that you will be exposed to new technologies. You will also know how the things are done differently. If you do not know, otherwise you will always thinking it has to be done this way. If you do not know, it is already there. That is why people who are doing a PhD, they may be knowing. You spend a lot of time in the beginning to understand where is the gap, where you want to do. If people who have already done, that's why you go back 20 years, 25 years and see what is being done. What is your first job? To find out where the gap is, right? Where the things are required. See, if you are doing the things which are already existing, spending a lot of time, what happens? That's why when you are preparing the scope of anything, don't be in a hurry. See, your 3, 4 months, 5 months delay doesn't make much difference, because you are doing it once in a life. So that's why make a thorough understanding where it should be useful. Then you will feel proud after a few years when you go back. See, I could have done this way. That should not be there. Delaying, we may be having a lot of issues, but at that time we have to be patient. That's why I don't tell for people who have done PhD you should have a patience. They already have. But it is true for other things also. We have to spend our time understanding, learning. So all, if you implement, you can change the things. I will give a few more examples. This is I have a couple more case studies. What is the main purpose of those case studies? I want to show you how the system is built and how it is implemented in the field. That is important. If it just remains in the regulation or in the books, it's of no use. It should come on the field. Then you will see the effects, right? So you can see, let's go back again, see hazardous levels. You can see how much must be the concentrations and effects. I want you to read and see what are the effects. I have given the health effects, and you also know where the sources are. Arsenic is also a big problem in major areas. Earlier, I think before DDT and all, people were using arsenic as one of the as a disinfectant or like that in the farming, right? And you know the health effects. How you want to let these things flow, even though if you don't fix them properly at the various at the basic level, if you are building the big infrastructures for a health infrastructure, how you are going to fulfill? That means you are knowingly you are doing the things, right? Prevention is always more important than repair. So cadmium, chromium, and copper. Copper in small quantities it is okay, but there is a limitation. We drink water in the copper parts, but to certain level, right? The hazardous levels you see, health effects you see, how difficult it is. You guys are in the field, you understand what are these contaminants. But many other educated people also you can ask, they won't have an idea, right? So that is why it is important to understand where we are at. See, right? I had an incident where city wants to liberalize lead limits, but I prevented that. See, that is what he will have to do. Because what happens, industries always want to plead. Because as the concentration of removal increases, the cost of treatment goes up, right? If you want to even see the turbidity, if it is reduced from 50 to 20 is easier. 20 to 10 is little different. 20, 10 to 5 is still different. If you want to make it almost 1 or 2, 0, it is still difficult. That is why it is important, if whether it is a drinking water or where you are doing application, you are doing a recharge groundwater, and if you are discharging it to the river, if you are discharging it to the canals, if you are discharging it to applying it to the crops. So that is why the perfect analysis is required. Planning is very important. You take little more time in the planning, and once you decide everything ready, then you go fast. So that is why it is important to understand the various component, various stakeholders involved in that system, right? Mercury, that is why you will have to find out the pollutant of concern. When we do inspections, we do audits, uh, then what is your main concern? Focus, pollutant of concern. You see whether this has been taken care of, right? You can analyze when you do just inspection. We don't see just the outer look and the office sitting in the office. Do the proper analysis. Take the sampling. They will be doing, but still there is an why you as a regulator or an authority, you want to do a sampling on yourself. You want to make sure, right? It is not necessary that they may not be knowing. Whether they are doing it knowingly or unknowingly is another aspect. So that is of your concern. If unknowingly, if it is happening, right, then you can see sit together. It is not something like that two different bodies, always you do enforcement, they do some. It is not like that. Some things they may not be knowing. But they are also people change. They are also people change. And you require all the stakeholders to be together to make it successful. And you need industry also to grow the economy. At the same time, your responsibility is to make sure that you have achieved the water quality standards and your environment is sustainable and safe. That is your responsibility. Everybody has to do individually their job properly. That is what the very intent of I have given this slide specifically to understand, right? How important your numbers analysis. Suddenly, it should not be a sudden thing. The environment doesn't happen suddenly. It has a lot of capacity, decades together. Nobody notices. Yesterday, I was very happy. People were talking, and one of our professor was talking about the burning issues in the river here. And we were talking that doesn't happen all of a sudden, right? That time nobody noticed, and today suddenly everybody is talking of why it should. I also heard there are number of treatment plants and only 10% of the treatment plant were working and rest were not working. Then who is responsible? The things which are built specifically, how you will justify this? Tomorrow you will be leading one of the unit like that. If it is not working, how that is possible? Wastewater is produced 24 hours, 365 days. If you don't take care of that, what will happen? Whom you will blame, right? So those things are important. So that is why you should always look at the pollutant of concern in addition to just BOD and COD. Other people talk, but you are a core environmental people who are much aware about the water quality analysis data. Your lookout should be something different. You look in a different perspective. It is not that just you are reduced. Your aim is not to just spend more time on the very generic pollutants, right? But you should also see the priority pollutants. Can you have the sources to find out how it is? So that's why you have to learn this analysis. That's why accredited lab means what? It has a certification. It has all the capability. Trained people are analyzing, and they have a modern equipment, accurate equipment. When when you ask about the data, always see whether when that equipment is calibrated or not. Just don't take the data. And if one of your assistant tomorrow, a group of people will be working, always have a double check. When you are making a major decision, you have to make sure your data are right? Whether it is done properly. Otherwise, what happens? The whole things will. If the doctor diagnoses wrongly, what happens? The disease which has to be treated, that will remain, and it will cause another disease. Similarly, like that. That is why you should understand the data thoroughly. Just don't design even the models just for 1 or 2 data, few months data. Make sure those data are very important. That is the language of the wastewater, how it is performing, what it consists of. Then you make a decision. Okay? And this I have seen how. I will not spend more time on that. Whole the industry discharge, receiving wastewater treatment plant, the component of solids generated and then disposed of, and also the interference in the treatment. This we have seen. Specific discharge prohibitions applicable to non-domestic users. What are the consequences? Pollutant which create a fire or explosion. Flash point should be less than 60. Should also aware of the regulations. It is not necessary to keep in your memory all the time. That's why we say operation and maintenance manuals, and different manuals was involved in developing many manuals. So those are important. You can read through, you can compare, you can see how the things are there, whether is there any requirement to change the design in the beginning. That is all can be done, right? Then solids, pollutants which will cause obstruction flow, that is we have seen, which will cause the obstruction of flows. Oil and grease in the system, it will cause a problem in the sewer system, it will cause a problem in the treatment. So that is why heat amounts will be inhibited in the biological activities. That is very important. If you allow any industry or any discharge which has high temperature, the biological activity will be spoiled. They are sensitive to temperature, right? How people are sensitive, they are also sensitive. So that is why you see, because the biological process, once it is disturbed, it will take a lot of time to come back. It is not just in a day it happens. So that is why it is important to make sure. How we will make sure? You will always keep analyzing the receiving end, the wastewater entering into the treatment plant. At every stage you will observe, you will take up samples, and you will say that the pollutants which are entering, they are within the limits or not. That is your responsibility. Make sure that sampling is done accurately at limited time. And how you will make a decision as a plant manager or plant staff. You should make sure, we are not able to find out this is accurate, so increase the sampling frequency. until you should have everything in plan, how that is what is coming in and what is going out. That is done through sampling analysis. You should have a good quality of data. You see where you are doing the analysis, whether they are done correct. You are trained people. Training is a lack of thing here. People say that I did so many years back, but you should always keep updating yourself. That will help a lot to learn and implement in your system, in your field where you are there, right? Then oil and grease, so we have talked about that, and any truck, all pollutants except at the discharge point. This is also an important thing. What happens, many industries, they don't have a lot of wastewater produced. If they may be producing maybe 1,000 gallons or 5,000 gallons, 10,000 gallons in a month or so. If it is highly concentrated, what they will do? They will have to do off-site, send it to off-site treatment. There are many companies which they do this job. They collect from different places, and what they will do? They will take it to the treatment plant and discharge through the trucks at the headworks. Then that plant people, what they will do? They will analyze that whether it is acceptable or not. It is not like that they have brought in a one truck and just put in the headworks. That is also possible. You have in a system where the wastewater flows into the wastewater treatment plant through this sewer system. But you also have many industries, they want to just collect in a tank and send it. Small industry, you can't expect that they should do a treatment plant. So that is why you have seen the different scenarios. So you should have from what is the source of the wastewater coming from, right? So the consequences you have already seen. What are the consequences if you don't analyze the wastewater entering into the system, right? The pH is also there. It should be within this to have a good biological system, right? And a non-contact cooling water in significant volume. Non-contact cooling towers, you have a big cooling towers, everybody wants air condition, you need an air condition in the company to maintain certain products, certain raw materials, central AC. That's why they contribute, they are considered as an um, cooling water, non-contact cooling water. What is the main contaminant in the cooling water? TDS, total dissolved solids, is the contaminant. So you cannot just put the enormous quantity of TDS in the wastewater treatment plant. VOD is what? It is a biochemical demand, oxygen demand that you can treat, or bacteria are well trained. But if TDS, they may spoil the entire game there. So that is why you have to make sure that the TDS is in line. If you just discharge, just throw it outside, what happens? That will enter the groundwater, right? So that is one of the things you should have, the understanding what kind of pollutant, what is the source, what is the volume, what is the quality entering into the system. Is it? Wastewater significantly affecting the system, hydraulic loading, which do not require treatment, right? If the hydraulic loading is there, if it is coming capable, suppose you designed a treatment plant of 5 MLD, uh, and if it is working at 2, if it is hydraulic loading is high, it can accommodate. But if it is organic loading, you have to see to what extent. That is why we do a shock loading study, how much it can take, right? You should have the understanding about that. Then regarding the industrial discharges, may be direct or indirect in discharges in the system. Significant industrial users, I said, who discharge average more than 25,000 gallons per day, means it is about 4 times 100,000 liter per day, right? If that big volume is coming, you have to be careful. They should have, this may cause a slug loading. Sudden big volume of wastewater is entering, your bacteria's biological treatment just collapse. So those things are important for the industries to look at. Its hydraulic loading, organic loading, pollutant of concern. Right? Categorical industry, we talked a bit about the categorical industry like metal industry, metal finishers, the contaminants which are difficult to remove in our system. Right? So there are, what they will have to do, there is a system they define what are the industry produce these kind of metals, these kind of a pollutant of concern, categorical industry. So there is a guidelines on that. You should have that guidelines. So then it is easy to understand from the source of uh, the contaminant. Oh, see, I want to give a little quick flash on what are the industry coming under this. You can see we were talking about aluminum forming, asbestos manufacturing, battery manufacturing, carbon black manufacturing, copper, coil, you can see all industry come under categorical industry. So what is the difference between the significant industrial users and the categorical industrial users? Categorical, it may be, volume may be small, but more contaminant. So that is why these are the industry you come across. Many of you have worked in this kind of industry, then you should understand the gravity of the issue. And petroleum refinery industry, right? Today we are more concerned about the fuel. We need fuel for our cars, and you should also understand how this, what it contributes, right? It is, you should, it is not the industry if they are not taking care what they are producing. That is the issue. Then there are three layers. We talked about that: the federal requirements, state requirements, commercial, industrial, residential, and different source from where the wastewater enters the treatment plant, right? What are the requirements to apply the pre-treatment program? Then you should see the location of the industries and what is the capability of the treatment plants and what is your local limits, how much it is able to treat, what are the pollutant of concern in order to maintain that, whether you have that resources, analysis to maintain the public infrastructure. If the wastewater treatment plant is there, if it is not working, means what? How it is built? It is built by people, money only. All the people existing in that place or everywhere, they are the stakeholders, right? You have invested there and it is not working. How that is fair? And provided written technical evaluation of the need, revise the limits, right? Technically, you will have to evaluate. You see, in the next lecture, we'll study about the biological treatment. You have in a different units, right? We'll study in detail. You have a grit chamber, you have in a primary, secondary, oil grease tap review, secondary disinfection, and then discharge. You should make sure that each unit is working properly. It is not the influent effluent. If just the water is passing without any removal, that you have to make sure that each unit is efficient or not. That's the big responsibility. I have seen people just sitting in the one place, not looking at anything, whether it is doing it properly or what a big waste it is. Waste on several end. You are not analyzing each unit how it is doing. You spend so much money and it is not working. One or other reason. There may be several reasons. But if you have spent so much of crores of rupees, if it is not working, is it okay? It's not okay. Right? So that, see how much big responsibility is there. Unless you create an awareness, understand. When you brought attention, then people start thinking why it should be like that. So those things are important. So that is why the technical evaluation is important. The purpose, what it is built, whether it is doing or not, right? And the sludge produced, where it is disposed of, how it is disposed of. All those things contain components of the wastewater products have to be analyzed properly. What are the rules? How it is established? Industrial user, we have a different users, and the control program, and what are the various components, interceptor, silver control, mercury control, all has to be there. When you do a survey, you should understand what it is producing, right? What you do, how you will understand that? If suppose a small unit came into your town, if you are officer, what you will do? You will investigate and find out what are the products, what are the raw materials used, how many people work, how much water is used, how much water is produced, where they are disposing it, how they are disposing it. All has to be analyzed. Then you can make a decision. If he is just starting something and discharging, who will do that job? What is the job of that unit which is built for? Then you will say, okay, if you don't want to build a treatment plant, it is fine. You collect everything what you produce and take it to other place. I have several example like that. I have done. No, can't do. You until you do your treatment plant, you keep discharge. But they listen. Otherwise, they will have to pay a lot of heavy fines on. But you have to do that. Otherwise, I have just started. I will see. No. First, see that. Go into the detail, and then you do. That's why in the beginning there is a system. You say how the people have developed. People who have developed. People like you and me and other people who are in the field. They have developed. They have seen several things and incorporated. Right. That is why when a new unit come into the town, they say do the engineering evaluation of what you do, what you produce. Then you will analyze. Then you start. You are hurry in starting the thing, not doing what is required. Inside everything is air conditioned. When the wastewater comes out, it is just left outside. Everything inside is good. Who will take the outside one? So that is why those are the things which have to be dealt basic. General prohibition, specific prohibition, categorical standard, local limits, best management practice. There is a small unit. You should, at the same time, it is required, but it should be, your aim is not to stop, but your aim is to, they should take care of the stuff what they produce, right? That is why best management practice. If a small unit is there, I gave you an example. If there is a car wash, small unit, you give them a best practice. You make these things, then you start doing it. You should know where it is going, how much they are producing, what they are doing. That is what you have to observe and take action. So you have several tools how it has to be done. That is why it is built so thoroughly so that there is no chance. Like that, you will also, if you do anything, you will go on improving. How you will do, when you make a document, you will read 10 times, you will do 15 times, 20 times, make it more consolidated, compact, well referenced document you prepare or not. You will not prepare one at one strike. That is how these things are built. But somebody has to take a step forward to implement it. For example, ability to locate loading, TSS and flow, ability to set specific local limits. That is what we talked more about, the local limits involvement in taking care of the uh, water quality, right? Control mechanisms. There are control mechanisms in place where you will have to make sure that things are done properly. Then right to entry, this is another thing. So here any official also, you cannot just go and enter in anybody's premise and start doing the things. That is the right of entry. That is why when you come in there, you will have to take a permission. There is a process how that goes. That is why you give an authorization. When you give authorization, there you will make it clear that the controlling authority, administration, has authority to enter your premise and do the inspection. That is required. If there is nothing, no documentation, suddenly you cannot go, right? That is why those are the things to be considered from your side of point also and their side also, right? Right of entry, surveillance, monitoring, in line with the right entry requirement, provide information requiring industrial user to respond to the survey on wastewater generation. Characterization will assist the treatment plant completing a robust industrial survey. That is why you have to do the survey. You have to start from there, right? Then the remedies, civil penalties, that is the next step, right? If you are doing your job correctly, if that is very important. If you are doing job correctly, everything you did, if doesn't happen anything on their side, that is for that you need a law. I did all this, but this is happening, so this is the way path we will go. Right? Then it is the civil penalty, criminal penalty, and then court and all this come into the picture. Then you will have to justify. That's why your documentation and data analysis is very important. When it goes to the court, if you don't have, in defense to plead anything, what you are doing is right, you just go away for a minute. So that is why what you do, what you analyze, what you report, that you know how the legal system works. Those things are important. That is why what you do is also important, how you document, how you analyze. That's why you make sure that data which are generated. Why data is important in this system? Because you can make a determination. You cannot say just good, bad, better, they are not doing work. What it means? There is no basis for that, right? It is a relative. Wrong and right is relative. He will say, I am doing right. He will say, you are doing right. This is relative. It may be doing right, it may be a wrong for you. But he may be doing it unknowingly or knowingly. There is no rule at all, or there is no analysis. So that is why this data should be representative. We always say the data generated is representative. Then health and welfare, remedies of non-compliance, environmental interference with the treatment plant, authorities, procedure, how to prevent discharge, they are always there. So if you are in a system, if they are not doing the things properly which is required as per the regulations, laws, you can stop, right? You can stop, you have the right. We will not accept the wastewater. But that system should be in the place. You have the right. people who are receiving the treatment side, these wastewater treatment plants, they have the right. So they can say we will not accept. So then they will understand. So you need a law for that. I will give a little understanding about the emerging pollutants. So we are not yet there. We are on the way to have a big concern on this. People who are already maybe knowing the consequences about that, right? So we'll talk a little bit about that also. Still it is in the very initial stage. Identify the industries which contribute to PFAS, right? First you will have to know the source, then you can find out from where it is coming. We will also come across what are these effects. People who have worked in the organic compounds, you know the consequences, right? Organic compounds like benzene, toluene, xylene, you have an, regulations for BTEX, right? Many things, if you do not know how you will make a law, right? Who will make? Yourself. If you are in that, if you ask anyone, what are the pollutant of concern, you should have a complete idea, right? Then you can make. In the beginning it may not be correct, but you will slowly you will improve, you will collect the data and make it. We'll talk a little bit about that. Any questions on this? So to summarize what you study in this metals, what are the different type of metals existing in the wastewater, and what are the health effects, right? What are the health effects of these metals? I allowed you to read it for a while. You can understand, no need to explain much about it. Already people are suffering on this. If they are not taken care of, they will start entering the water quality, water bearing ponds. It will enter underground reservoirs, it will enter streams, rivers, everywhere. If it is in the sludge, you cannot do anything. You don't have other way to dispose it off the site in the landfill. How much you will keep disposing of in the landfill? You can also make it productive, but you build the treatment plant with an intent to create a manure out of the sludge generated, because you are treating a domestic waste, right? But if the metal is in the sludge, the very purpose of your plan is spoiled. What happens? You spend a lot of money to make that system to work. Because of these contaminants, they cannot be used for that purpose. Then in addition to that, you are taking a space in the landfill. You see the management, how much loss it is. You are not creating a loss at one place, in multi places, and you are creating a problem. So that is why these things are very important in the treatment system. You cannot just think in one direction. You should think in all the direction. To think in all of the direction, you should understand what are the various components related to the treatment plant. Right from source of production to treatment technologies, efficiency of the treatment system, what is built, how it is managed, how the data analysis is done, right? whether you are able to recoup the cost, where you are disposing, whether it is fulfilling the purpose what for it is built, right? Then whether you can make a productive substance out of this waste, right? Yesterday somebody was asking about reuse of the water, right? But if we have these contaminants pass through, what happens? You build a plant with a intent to reuse the water, so that is very much spoiled. One way it is not doing the purpose what for it is. If you are applying that to, you are also creating another problem for the soil people and the water body. So it is not solving the purpose. You are creating additional issues. If they are just discharged outside, you are systematically bringing them here, not doing the things and creating a number of problems. That is why the purpose what for it is built is important. Your role is very important in that. Wherever you are, whatever you are doing, if you are related to any wastewater treatment plants, or you may be on an industry side, is it? And or you may be on the regulation side. Maybe those things are very important. They should do in a collaboratively do the job correctly. That's it, right? That's why we have a lot of NGOs, and it is a responsibility of the people also. They should aware what is going on. We do public notice whenever new industry comes. That is the rule here also everywhere. But what happens? It will just remain in the newspaper. Nobody will see. Is it the professor? Is it the example? Anybody has done a public comments what this industry is there, what they are doing? Are they aware? Anyone has done? Some people. Ah, I agree. See, that is important. I appreciate those heroes who does that job. Is it? That is why I want you to be like that. Wherever you are there, after learning so much, if anything is happening, if you are not having a concern, just a people who knows the things don't do, and who don't know, both are same, right? So that is why wherever you are there, you should ask question, you should find out, you should say something. Is it? I want to give you an example. I was reading somewhere, in one of the intern was doing some project on the lakes. I think that girl was going from different areas, finding out how many lakes. Today we have lost more than 50% of the lake. That's why to you seen there was a lake here when we are small. You stories you hear, but that is true, right? So the girl started finding out what are the lakes, what is the area. You will see area. If you check the area of the lake is different there in the system, and existing is nothing. So all the entire area is filled with houses around. There we are smart in doing that, so, right? So started finding out, like some people, you said, I appreciate some people like her, went to the press, went to the regulations, went to meet, collected a lot of people, did the protest. Then people were aware. Then they were able to remove the structures which are built there, and some NGOs came up, started working on those lakes, and today you find a beautiful place. See, just a small trigger. There was, I heard, there was a threat for that girl also. Lot of people who were there already acquired. They were, uh, you know, taking and threatening not to do this. Many press reports. But some people come forward. See, very nice. Saved the lake. What is the result? Just one spark, one trigger saved the lake. So this is how there are many examples. It is not like that nothing is happening, but slow rate. But as people grow, people understand, people understand their right, people know the consequences, problems, issues. If anything is happening, they should be bold enough to make statements. People, at least they should aware what is happening. Then there will be some people who can come forward, take next step. So that is what I would like to say. When you go with something, you'll study a lot of things in the classrooms, and you will also teach. Whenever such problems comes up, you will have to move forward. There should be something, what you are doing, you should do right. So if you don't take action, if it is say okay, then the whole thing will suffer. Even in advanced countries, these things happen. If you don't, you can do just a job, or you can step forward and make it right. That's why you should have a passion to do them. You should have an understanding. You should have a perfect documentation that is required. You should able to create awareness. Public participation is very important uh, in this system. So that is why you should be able to speak. When you speak, I'm happy. That's why I tell you to ask questions, see these are the issues. I talk to some people, they are so active, and see they are understanding the problem, they are discussing. So that is how it spread. Tomorrow you will be here and you will be talking to them. So make sure that things are spread, people are aware what is happening, and you should also aware. Just do the thing, and whatever good work you do, you document and make it available for the people. That is what I have learned. Whatever I do, I've done all this one page report so anybody can follow. That is why you do publish your papers, so that other people can read, understand, and start doing the work, right? That is all. It may not be only the papers. Any document, any work you do, make it sure that is available, documentation, record, that is important. You will also feel proud. Sometimes I used to write a lot of articles. I have written many chapters, of course, journal papers, conference papers, and some articles. See, if you look back, you see at that time, see, you feel proud. You have done something and document it. That is why it is important what you do, right? Make it aware. How much is impact, that is different. Whether it results or doesn't results, that is not your job. Yeah. It is, don't be on the negative side, nothing will happen. It is in the environment, it is not like that. It takes time. How it takes time to get pollute completely. See, today people are talking about the river after how many years? It took many, many decades, the spoiling. Today you are talking, right? And now all of a sudden everybody is active. They show plastic and make a picture and give advertisement. I think 5 minutes break. If you don't have a question. If you have a question, I will wait for 5 minutes, right?
If any of the candidate.
Good morning to all. Thank you to Professor Vijay Kubdat sir. You gave the informative knowledge about the heavy metal ions in industrial wastewater. I will take such points you have gave us. You gave information about what is the National Pre-Treatment Program, what a POTW is treatment work owned by state and municipal, why POTW designed, and you gave valuable information about the permissible limit of different heavy metal ions and their health effect, environment issues, how to detect these threats by using AAS, liquid chromatography. You also gave the information about different regulations in USA, and you gave information about 5 types of pre-treatment standards. We are enjoy with you, and thank you to all. Thank you, sir.
Thank you. 15, 3, 3.5. Then you will go either you will not adjust the to the 100 at all. So that is how it is. So I want you to write a half page for yourself what you learn. Right? What that is important. So then what you are going to learn, you will see here how it is reconnected. Is it? That is how I wanted to tell you how what is this whole program is. I have told you what are the different components in the system. There is a treatment system we studied, then we studied the sewer system, the collection system, then the biosolids, water quality, effect on soil, effect on human health, right? Then the regulations which manages different layers of regulation, I mean level of working, federal, state, local, public participation. You work with a different group of people, consultants, regulations, industry, public participation. See how many components you are working with together. So that is how I have this course has been built like that. Whole. Then part by part we are going. So that you will have a complete understanding what you have studied, how it is done in all direction, right? So that is the intent of that. So earlier I used to mention about the biological treatment. So that is what we are studying. See fundamentals of biological treatment process and its importance, right? Outline. I have given you the glossary terms. Please read them. That it is in the soft form. Um, I wanted to give you hard copies, so we have to save some trees also. But if you read, that is useful. It should not just remain in your computer, right? So those are the terms in the field of wastewater treatment, in the field of environment. You should know what it means. If I say BOD, you should understand what it is. That is the fundamentals, right? That is why I am saying BOD, but sometimes I explain. But there are other terms, several terms also there. Is it? There are a daily discharge, there are monitoring what is pH, what is nitrate, what is nitrogen, right? What is ammonia, what are the limits, what do you mean by limit, what do you mean by a wastewater treatment plant, what are the pollutant of concern, right? Everything is there. There may be some more, but the major one, why what we do is we read that. That is already there. So we activated sludge process, carbonaceous VOD, right? Removal, nitrification, TS removal, activated sludge data requirement, regulatory data, process control data, common operator error, right? So operators are very important. People who manage that system. That is why they have to be certified. Just by experience, they are doing some of the things for many years. They want to do this. You need an upgradation. People who are working in this system, they should learn new things, right? They should. If you have to update yourself, it is going so fast, right? Earlier, if you just go back 10, 15 years, nothing was there, right? Things have changed in the field of computer, is it? But you have to learn, you have to move forward, you have to understand, because you have to work with advanced technology, right? In order to make it more efficient. So that is why it is important to understand the components which are required, tools, resources are required to manage the water quality, safe environment, right? So common operator errors, what they happens if they are not trained, what will happen? You know the consequences. You have to do it rightly, correctly. You should have a manual available on the site. Operator, he will work for 8 hours and go away. New operators come in, he will see the manual. New person will see the manual. If something happens, they're all in the emergency, what he will do? If spill occurs, what he will do? All it is mentioned in the manual. That is why when the treatment plant is built, we ask for an operator manual, operation and maintenance. Flow will change, cities will grow. You cannot design a system which is required today, right? And of course, there are sudden change in the population. City grows suddenly in some areas. Lot of big industries come in, then city explodes. That time you have an additional treatment plant, or you can update. When you update your all manual, every system will change. So that all you should have an understanding in that. Reduce aeration, reduce nutrient discharge. See, once you know how much is aeration required, that is all the design factor. They will design in the beginning, but you should see that that is implemented, that is working on the field. Working on the field is important. It is not like that the design and working on the field are two different things. People say, oh, it is in the paper. It is the, there is a base, there is a link. Efficiency you design maybe 95, here it is 9. But you can tune. Any design is, you need a little tuning when it is implemented on the site. Is it? Many I have heard many engineers saying that, oh, theory is different. This is not different. This is same. What is to be implemented on the field is same in the design, but still you need a tuning because there are number of parameters. In the design, you will assume certain parameters, but not exactly the same. It may be a little variation. That is why you will have to make sure that the things are working on the field. It needs a little tone. That is why don't have a belief in that this is different and this is different and just you want to just go away, walk away from that. No, it will work. So that is why you should make sure that these things are working on that. If you know this, you can save energy. Energy is a very important. Lot of energy is required in the treatment plants. If it is a active test, we will come across a different type of biological tests, treatments, systems. We use a lot of energy in the treatment system. So I will go a little bit quickly about this glossaries which are commonly used in the treatment system, in the biological testing. Why biological treatment systems are more famous today also? Because it is done by a bacteria, microorganisms, right? Microorganisms are do a very great job for the people. So they convert the unstable organic compound into a stable organic compound. Oh, water and carbon dioxide converted into water and carbon dioxide. Reduce the organic loading, right? So they do important job. So in that case, you should know what is organic matter, how much is reduced, what is aerobic treatment, what is anaerobic treatment. I have given in the glossary. You can also, I just wanted to brief a little bit about that. Quantity of oxygen required by microbes in the oxidation of organic matter under aerobic condition. Aerobic condition in the sense in the presence of oxygen, anaerobic in absence of oxygen. What is the difference? Detention times are different. Oxygen supply, there are bacteria which are more efficient in aerobic condition. There are bacteria who can work in absence of oxygen also. That is what your digesters are. So then suspended solids, solids in the suspension larger than about 1.2 micron in size that can be removed by the laboratory filtration techniques. Right? So if you are telling to someone BOD is this, suspended solids are this way, so how you will define for a third person? So that is why you should have an understanding for yourself when you are making a statement. Then biomass, living biological matters. I will go a little quick on that. So activated sludge process, a biological wastewater treatment process in which a mixture of wastewater and activated sludge. Why it is called active? Because what you do in the activated sludge, we will go further, you will understand much better. When the sludge is there, 2%, 3% of the sludge, 10% of the sludge is again recycled. You want to keep it active sludge. That is why it is activated sludge process. Because what happens in the aeration tank, organic matter is converted into stable compounds. And in the next clarifier, these bacteria are removed as a suspended solids. Then part of that you recirculate to the oxidation, to the system. Because they are removed as a suspended. See how important work they do in a fraction of a second. Right? So activated sludge is aerated in the reactor basin in aeration tank. Biomass is settled in the final clarifier with the most biomass returned to the aeration tank, while some biomass is wasted. Some is wasted, some is right. That is why the sludge which is coming from the secondary treatment, you send it to the thickeners, right? In the first, in the grit chamber, the waste produced, the grit produced, you send it to the landfilling because they are solids. This still consists of bacteria and moisture. It goes to the thickeners, then it goes to the drying beds. Then return activated sludge, settled activated sludge that is returned to mix with the raw or primary settled waste. Right? Then waste activated sludge, the quantity of microbial solids that has to be wasted from the system at the rate it is produced, same as the excess biomass. Okay. So we are entering into the treatment system now. I'm giving some basic understanding about the terms frequently used in the system. Sludge age, the average time of the day's microbial cell remains in an activated sludge, same as mean residence time and solid retention time. Right? Bacteria also has an age, right? So that is why you need a recirculation. Mixed liquor, a mixture of wastewater and activated sludge undergoing aeration in the reactor basin, reaction tank in activated sludge process. MLSS, mixed liquor suspended solids, the suspended solids concentration in the mixed liquor. Okay. Settleability, how well the biomass settles, compact, clears the funnel. That is important. It has to be settled. That is why you give a sufficient retention time so that they can get it. Right? Nitrification, biological conversion of ammonia nitrogen to nitrite by nitrifying bacteria. Is it? Nitrite is unstable. It is converted into nitrate. Reaction is done. If I say that there is no organic compound, means what? The reaction starts as soon as the wastewater comes out of your residence, because it has a bacteria. When all the organic matter is converted into water and carbon dioxide, reaction starts. That's why when you go near the wastewater treatment plant, it has some odor. You feel that. That's why people working in the field of wastewater, see, cleaning the waste which is produced, they are great people, right? All the time they are there taking care of the stuff which is produced, right? They are very important component of our whole system, right? They do a great job. It is very easy to work on the table, work nicely and go home. Like people, you see, this waste is treated and make it compatible, then discharge. That's why you see who are the stakeholders, how many people are involved in order to make the whole treatment system good environment. If it is good, everybody feels happy, right? But you have to work towards when somebody shows the pictures in other places, oh, it's so nice, how nicely they are maintained. Some people have worked for that, right? People who are there, they have worked for that. The same should be like here. When everything is good, people like. Construction also, a lot of people work and make a good, big, nice house, and they go away, they will forget. The people who are responsible of making is important, right? We should always have a gratitude to them, right? That is what. So, nitrification, denitrification, in the sense biological conversion from nitrate to nitrogen gas. What happens? The reverse atmosphere takes. Nitrification, denitrification go hand in hand. A nitrate is converted into nitrite is, and then the nitrogen gas, right, goes out of the system. Anoxic condition, there is a condition exists between aerobic and anaerobic. That is why we want to make sure that the wastewater is always in a continuous motion. Otherwise, what happens? We want to create an aerobic situation. If its sludge settles all the time down, it creates an anaerobic condition. That's why we want to make sure that aerobic system is working. Right? So anoxic condition is in the sense in between. Why there are three conditions now here? Aerobic, anoxic, and anaerobic. Different bacteria exist in that conditions. Right? So that is what. How we will do that? You can find out what kind of bacteria are available. Right? You might have heard heterogeneous bacteria, filamentous bacteria, fungi, many bacteria. Different condition, situation, different bacteria, different capacity. So, anaerobic conditions when the mixed liquor has no oxygen. There is also a provision. If oxygen is not there, still you can treat. If it is a high organic content, what we do? We do in an anaerobic situation, reduce lot of BOD, then we put to aerobic conditions and different ways, combination, designs, depending upon the type of wastewater it is. That's why I was telling you, it depends. What are the influent concentration. Accordingly, we will design. Domestic wastewater has an BOD around 300, 400, 500. If you take a ratio, F by M means what? Food to microorganism ratio is 0.5. We say it is degradable. 0.6, 0.7, it will be difficult, right? That is how. Industrial wastewater, less BOD, pollutants of concern. That is why we are worried. That's what we do. We mix certain industrial wastewater into domestic wastewater, make it compatible. It can take some, right? That is how the system is designed. So in a different conditions, accordingly design is. Facultative heterotrophs, bacteria that use organic matter as their carbon source, can thrive in the aerobic, anoxic, and anaerobic mode. Right? Different. Endogenous respiration, the continuous process whereby bacteria oxidize their cell mass to produce energy. Right? What it does, 2/3 energy is used to convert organic matters into a stable compound. 1/3, approximately 1/3 is used for their production. Bacteria, number of bacteria will go on increasing, right? That is how your food to microorganisms ratio. When the food is reduced, number of microorganisms are more. What will happen if the food is not available? Microorganisms deterioration takes place. They are removed in the next treatment system as a suspended salt. See how phenomenal it is. They do a tremendous job in removing the waste which is produced, and the next stage they are removed as a suspended salt and disposed of. So that is why bacteria play very important role. Right? They do a toxic, reduce the toxic substance in a fraction of second, and then they are removed from the system. Then again, new bacteria will come and take over. So this is how it is. Types of biological treatment, activated sludge process, still it is popular, right? An aerobic process that uses a high level of oxygen, nutrients to treat sewage, trickling filter, aerobic process that uses a bed of rock to break down organic matters. This is called attached growth. There is a media, wastewater goes into that, there is a thin layer, then the organic matter is converted to a stable compound. Attached growth. So attached growth media is there and wastewater is passed through. Activated sludge process, it is slightly different. There is a tank where the aerators are fixed, and you have seen the activated sludge process yesterday, correct? You also seen the aerobic treatment yesterday. I have shown some videos, right? And in earlier visit and today's visit also, you will see some of the biological treatment systems, how they are done, right? And you have seen how the wastewater in the beginning and how the effluent is. See, you are able to do that if you do the things correctly. You will. That's why you should measure at each stage. Each unit is working properly, and the end product is the phenomenal waste. I mean, the effluent comes in, and then accordingly you can use it. You can recycle, right? So, rotating biological contactor, a system that can be used as a secondary tertiary treatment process to remove BOD5 and nitrifying wastewater. You can see many papers of mine on this. We have worked on a biological treatment systems and also oxygen transfer, how the oxygen transfer takes place in the wastewater treatment, biological treatment, prototyping design, and see, make sure that designed system works there. Whatever the oxygen is needed for the biological system is able to produce by the equipments you have used. That was where there is a mathematical model which had, proposal is, is there in the system, and which is more efficient. By that you can design the system. Oxygen transfer in the rotating biology. An advanced treatment process that removes the suspended solids, the dissolved substances from the wastewater after primary secondary treatment. Right? See, that is important. You should make sure that there is no pass through. If the pass through is there, it will cause a problem. Right? So different biological treatment process. See here, this is how the system works here. Preliminary treatment, primary clarifier, secondary treatment, aeration tank, secondary clarifier, nutrient removal and disinfection, and final effluent. Disinfection is also needed sometimes. You can also, you saw there, I think in the visit they gave an ultraviolet treatment, right? Disinfection. Or you can use also, why? When you are discharging it to the river, we try to avoid dechlorination. Today, ultraviolet is the best method for if you are discharging it to the river and stream. If there is a residual chlorine is high in content, it may affect the fish growth and fish ability, fish movements. That's why we want to make sure that when you use chlorine as a disinfectant, in case of water supply, we use chlorine as a disinfectant. Why we use chlorine as a disinfectant in drinking water? What happens? You treat the water at some place, then you put that water into a distribution system. Before it reaches consumer, it should not get contaminated. That's why we keep a residual chlorine about 0.5 mg per liter or 0.2 to 0.5 mg per liter, so that before it reaches the consumer, if there is any contaminant in the system, that is taken care of. There we use. But if your source of wastewater treatment, discharging it to the river, you don't want to use disinfectant. The chlorine as a disinfectant. Ultraviolet is the earlier, it is well developed now. In many systems I have seen, they have converted the use of disinfectant to ultraviolets. Technology is expensive in the beginning. As we move forward, it becomes less expensive, more efficient, because when you are discharging it to the rivers and streams, you want to make sure that the chlorine should not affect the fish population in the rivers and streams. That's why we use something. See the overall system. Wastewater treatment system enters, preliminary treatment, you will remove suspended solids, grade or floating, everything, which is whatever you oil and grease treatment in the beginning. Is it? Many people just throw oil and grease in the sewer systems. That all may cause a problem. If you carry oil and grease, if you are not designing the wastewater treatment system without the oil and grease trap, after grid chamber or before that, what happens? You are carrying that oil and grease continuously unto the end. Your treatment efficiency reduces. See how important it is. So all this component work together. That is was I was mentioning in the earlier lectures about the fog programs. You should make sure how many restaurants have this facility here. Is it? You go to restaurants. No? So how many restaurants have a grease trap before they discharge? Right? What will happen? Who will take care of that? So those things are important. Different component which contributing the hindrance, issues has to be fixed. That's why you see what are the different components in the whole ecosystem. If you work all the system is built like this. You have, that is why each stakeholder, each component has to work efficiently in order to make it successful. Right? That is why in the beginning I was telling that I want you to write lecture 1 what you understood, lecture 2 what you studied, 3 just half page. Right? Then you will understand how the flow went from right from the beginning to the until end, to the success story. I also give some tutorials how this is implemented on the site. That's a big difference. They are not small industry, they are very big industry. Well mechanized, 1,000 people working, millions of dollars. If you work and reduce the pollutant at the source, that is possible. The same thing should happen. When you go out same with the same mission, same mindset, you should have. Right? Wherever possible, try to implement them. Wherever, whatever job you are, do that right. Spread the right things. So you can see the different components of the treatment system. Primary clarifier, aeration tank, so aerators, secondary clarifier, nutrient removal, disinfection, final effluent and sludge is collected in the digester and that is sent to. So we want to remove the gases also. Collect the methane and the sludge is sent to the thickener where we remove water and the sludge is then disposed off to the dry beds, or it can be used as a manure if it doesn't have any pollutant of concerns, metals, right? So you can see the aerators, how the aerators are there. I have taken some pictures of the built. That is how you design. What is the volume of the wastewater in the tank and how much is the oxygen required? So that is a good balance. You should be able to understand in order to have it. They are not randomly fixed somewhere, right? So you should make sure that each corner, the wastewater, bacteria all get the right oxygen in order to reduce the organic compounds present in the water, right? So these are the areas. So wastewater, see, you can see the pumps here all the time. You should have a standby. If that fails, you should have a standby. You don't have a choice there, right? Because wastewater is a continuous process. If if it fails, what happens? The system, whole system, you have to have a bypass sometime. Very purposes. That's why we have one set of standbys and another set of standbys. Then a biological reactor, clarifier, and then return of sludge. That's why it is called activated sludge process. Sludge. Return of activated sludge is recycled back to the biological. What we will learn today: to identify, understand primary activated sludge process, goals to identify, understand primary data requirement needed to operate activated sludge process, recognize common operator errors, how to eliminate them, right? Reduce aeration to achieve energy and money saving. That is important. If you no need to put something extra in order to become efficient, if it is not useful. Because if you put a aerator continuously 24 hours If you are putting even 10%, 50% more, what happens? It's a waste. Need a lot of energy. If you are putting under, what happens? Treatment won't take place. Untreated wastewater will. So that is why it should be appropriate. That is what is called in a design, right? So reduce aeration to decrease the nutrient loading, discharge to the receiving water. To understand the activated sludge process better. Activated sludge process, you know the carbonaceous removal, nitrification, TSS removal, maintain neutral pH. pH is very important. It is a very small and easy to maintain. But if you don't maintain it properly, it will cause a big problem in the biological system. You need you will have an online flow measurements. Today you can monitor it well. You can have an online system where a person can see how the wastewater is in progress. Everything you can do. pH is also very important. But what happens if there is a variation in the pH? It will affect the bacterial growth. The very treatment will get upset. How we will find out you need an appropriate pH? You should have a measurements. That's why I say that first when I go for a visit and see whether you guys have calibrated your pH or not, instruments or not, right? If it is not calibrated, 10 may be 12 or 10 may be 8, right? So they are simple things. You should have a mindset what to see, right? That is important. So minimize the quantity of solid produced to optimize the energy, denitrification and phosphorus removal. Phosphorus removal also you should see wastewater how much phosphorus is consist of. Then if you are just removing leaving the if the effluent consists of a phosphorus, what will happen? Growth, algae growth and all will start taking place there. So that is why it is important to maintain the phosphorus removal also. Successfully activated sludge process performance is judged by the effluent quality. How we will judge whether the treatment is working? You will see the effluent quality all the time. Measure that and then use it for other purpose. If you are not measuring it properly, if you are discharging or using it for other purpose, you are creating another issue. First, you are not doing this is right and you are giving rise to another issue. Right? Achieve an excellent effluent quality while achieving our process goal, minimize energy use using plant equipment efficiently. See, you should save energy, you should have a effluent quality, then efficient equipments. They are important. If you are using an equipment which is a old one taking large energy, you don't want to first understand what is required. I think I remembered worked in one of the project where for cooling towers, where the earlier, long back story now, they are using a seawater as a cooling tower water to reduce the temperature, because water is very important. In the cities, big cities, you bring a water like this in the bottle, but if it is in a refinery, they use a lot of water. I think leather industry also uses a lot of water, correct? Somebody was working and mining uses a lot of water for the process plants, cleaning. So you don't get a water. So what they can do? They were using a seawater. See, if they are using a seawater, it's a once through system. Temperature is to it has a high temperature. When you passing the seawater through that, what happens? Concentration increases. Then you cannot recycle. So just discharge it to the sea again. See, you can do anything people are doing. Where there is no resistance, anybody can throw anything. That is what the system. So later what happened? They have an understanding. They said, municipality produces a lot of sewage. So what they did is, they brought all the sewage to their industry. That municipality was very happy. Somebody is taking a sewage. So they were ready to give a sewage. They made all the initial work. They brought sewage. Sewage is produced. People are not ready to take care of that, right? If somebody is taking care, they are happy. So did that. That the, I think, group was working on that. So brought the sewage from the municipal to their industry, and they treated the sewage. It is good win-win situation. So they treated the sewage. That treated effluent quality was such a nice. They were using the same water as a cooling water 17 times, and then they were discharging. See how much volume of the water is reduced. You did a great job of bringing the sewage, treating it, and using it for your purpose. And what is the big reduction? Once through system, you have to pull lot of water, energy, to bringing that, water to your cooling system and passing one. It is a once through system, 17 times more than the water required. You are taking the seawater. Now it is 17 times less energy. Started saving a lot of money in the energy itself, and also the municipality was happy, right? So this is how you can see the different ways of using the technology and how it can be done, right? So both are happy. So this is possible. So these refineries and all use a lot of water for their as a cooling tower. Conventional activated sludge process are primarily designed to remove CBOD, means carbonaceous, BOD and TSS from the waste. Organic loading entering the activated sludge channeled into two directions, growth reaction and energy. Right? Growth reaction, organic nutrients, biomass, new cells are produced. By the growth reaction, biomass is produced as a result of consumption of organic matter. That is what I said. So bacteria, they use some energy for their production, and also they do a great job for the humankind. So they will reduce the organic matter to a stable compounds, carbon dioxide and water. Right? Sludge production, solids produced per day, solid retention time. Organics, oxygen, carbon dioxide and water and energy. Right? Oxidation of organic matter in the wastewater is accomplished biologically using variety of microorganisms. Primary bacteria, the oxidation reaction produces energy for the bacteria. We use a heterogeneous bacteria. They are very efficient in treating the wastewater. But if there are pollutants, what we will do? So we try to acclimatize these bacteria to remove the specific compounds if it is a toxic. Even like cyanide, certain industry, fuel industry, refineries. See, we are very happy if the gas prices goes up, gas price comes down, we are very happy. Right? But they also produce contaminant like cyanides. So there are bacteria which reduces that also, that we try to acclimatize. People who are working in a biological treatment plants, they know how you do. There are a group of heterogeneous bacteria. I have done that. So that's why I'm telling you. People are very heavy, right? They don't leave even bacteria. So bacteria, organic matter, if they are reducing heterogeneous bacteria, what we will do? We will put 1 gram initially the toxicants, and 2 gram, this will reduce 2 gram here, 2 gram here, 2 milligram here, 3 milligram up, 3 milligram down. We train the bacteria, right? We acclimatize. We make sure that what happens, bacteria which are efficient in removing a specific pollutant, they are there. We make sure that they are there, and then right, we're able to remove cyanide up to 80 milligram per liter. So, but we go slightly different technology on that. When you are using a toxic, rotating biological conductors are very useful. In a active test sludge process, if it consists of any pollutants, what happens? If there is a dose is little higher, it will spoil the entire system. That's why we want to make, we use attached growth system. We want to pass the wastewater down. 3/4 of 1/4, 2/3 of the wastewater, submerging into it, and then we pass the wastewater. So bacteria is on the top. It will catch the pollutant and treat. So this is so if it is a toxic, there are advantage, disadvantage of different technologies. In widely we use a activated sludge process because domestic wastewater, and if they are capable of treating it with the heterogeneous bacteria, nitrate, nitrogen bacteria are also present. If it is consist of nitrate, phosphorus, other organic compound, we use a activated sludge process. That is most common. You have seen that in many places. But we have to go to that extent also, remove specific compounds. Right? We should not be happy. If you are not measuring it, no pollution. No measurement, no pollution. Everything is fine. That should not be there. But thorough analysis we do of the influent first, what is present. So accordingly, you can design the system. Yesterday, somebody asked me a question in the industry, why you chose the reverse osmosis process, right? So that is important. We see if the TDS is there, it's no point in putting a activated sludge process. This reverse osmosis process is more efficient in reducing the TDS, dissolved solute. Even you will not understand how much is the dissolved there. It looks good because it looks like the treated effluent, but it has a dissolved solids, right? So that's why we go for that. That's the pre-treat. Then we discharge. It has a BOD. It may not be more efficient in removing the BOD, but it removes the TDS, which is the main concern. Then BOD, which is remaining BOD, it will be discharged to the receiving treatment plant, and that is taken care of. This is what this portion industrial side is a pre-treatment, and there it is treated. So this is how we take the advantage of this treatment technology. So oxygen requirement, I said oxygen requirement is very important. You should make sure that the right amount of oxygen is available for the bacteria to reduce organic compounds. Then there are some numericals about nitrification, and yesterday you saw one video how that takes. I will go a little faster here. So you have seen how the nitrification, denitrification, they go hand in hand simultaneously. What happens? Ammonia converted into nitrite, then nitrate in the denitrification process. What happens? Nitrate is converted into ammonia. That is how it is treated. During nitrification, alkalinity is needed to buffer up the pH. Alkalinity in the sense you need a higher pH, right? Any questions on that? So what you learned is in the biological system, what it consists of, what are the terms and conditions, right? How the wastewater enters the treatment system, right? And how you are taking care of the general domestic wastewater. It may be a BOD, may be higher or lower, doesn't matter. That is what we do is in the pre-treatment world, we use the industrial wastewater, right? The industrial wastewater produced has a low BOD. So we take the advantage of that, right? If you see here, little back, in the nitrification, we do the denitrification. That is how we do. In case of the activated sludge process also, what we do, industrial wastewater has a less BOD and domestic wastewater has a BOD. So we want to mix them, take the advantage of. But that is why in the pre-treatment world we tell the industry the pollutant of concern must be removed. If they are producing a toxic, if it is a categorical industry, what happens? They just can't discharge everything and mix it with the domestic wastewater. That is what our system is. We will treat partially, you pay whatever the amount you are discharging accordingly. That is how the agreement. Different industries, you can't take all the wastewater mix with the domestic and treat. You analyze. They are called a tributary industries. When they are discharging, what we do is make sure that if it is a metal industry, toxic substance can be removed. If it is a food industry, it has a lot of suspended solids. You just can't discharge. You have seen the example of the case studies, right? They produce a lot of suspended solids and high BOD. So what we do, they are discharging it to the domestic wastewater treatment plant only, city's waste treatment plant. It has a high BOD. If it is more than 1000 milligram, you just can't discharge. You cannot overload. If it has a suspended solids, it is suspended. Food processing industry have a lot of suspended solids and a high BOD also. So in that case, they say that reduce the suspended solids concentration to the level of 300, 200, then you discharge. So what they will do? They will build a big settling tank, series of tanks. It may be geomembrane, because if they are producing a high volume of wastewater, you cannot ask them to have a concrete tanks. If it is a volume is less, it is fine. That is why what they do, big acres together, the geomembrane, double lined, it is a mandatory. If it is a industrial wastewater, it has to be double lined. So they do 2, 3, a big geomembraned the ponds, they are connected each other, and then the suspended solids settle down, reduce to the certain range, and then they discharge. If it is a high BOD, I said they have a suspended solids, high concentration, high BOD also. So they put a DAP system. You have seen yesterday the DAP system there. They have a settling tank to remove the suspended solids, and also a DAP system where the oxygen is added so that the BOD is reduced to some extent. If it is 1000, you can reduce it to 800, 600, then we will discharge. We will take rest of that. So this is how the system works. That is how you have to see what kind of industries are there, right? Then accordingly you will have to design a pre-treatment system, then discharge. If there are certain places where the number of industries are more, you cannot ask all the industries to discharge, we will take it. You do a pre-treatment and then discharge. Sometimes it is a not possibility. That is why city sometimes what it does, it builds two different treatment plants. One is domestic wastewater treatment, that is the mandated, that is called POTW, which is publicly owned. See, the name is publicly owned because people contribute. If anybody says the city sewage treatment plant means it is your own treatment plant, right? And nobody is taking care, right? That should not be there. And you do not know also. See, that is your own built by your money only. That's why the name they give. That public should understand it is ours. Sewage treatment plant means it is somebody. So that is important. See, that is yours. So what they do is, if the number of industries are more, then they build a separate one just specifically for industry. If 10 are there, we can put 7, 8 there and 2 here. That is how you should have an understanding. It depends upon the capacity. I have dealt with many industries there where industry goes on expanding. If your city treatment plant remains at the same level, what happens? There is a problem. So that is why the common effluent treatment plant concept came into existence. All small industries together, they build a common effluent treatment plant, then they discharge. And based on the volume and the concentration, there are some management experts are also here, they can work out based on the organic concentration and the flow. The cost of that is divided. So when they will run properly, because the stakeholders are there, here public means the whole public, maybe millions of people there, half million is there, quarter million is there. Industry giants will come together and they build. So then they try to run it efficiently because they pay for that. They have to pay as per the concentration, as per the loading, the volume. So that is how this common effluent treatment concept comes. But the problem is, if they are in the industrial zone, they can have an efficient treatment. But if the industries are located at different places, suppose you have many small industries existing in the corner of the cities, who will account for them? So they will be discharging the wastewater to the sewer system, but still it is the responsibility of the city's treatment plant to treat. So that is why nowadays what is happening, they are trying to make an industrial zones in a particular area, try to shift the industries which are existing in the other area. If it is a big plant, they can have that capability. They can build their own treatment plant, and then they can also put a pipeline to discharge the wastewater to, depending upon the quality of the wastewater, to the creek or to the river, or they can do a land application. They have that much resource. So this is how they are trying to do it, but it takes time. Now the new cities and towns, they are built with the concept that there is an industrial zone and residential zone and the public place and the future expansion. This is how you have learned in your engineering and your schools. It has to be there, but at least the new areas should be like that. So then it is easier to plan. And there are hospitals also, clinicals also. You have to make sure that the city has to make sure they are treating the waste coming out of that system, should be taken care of that. We have a program there for the cities. This time, okay, I have little 15 minutes time. So we have a program called the fog program where all the restaurants and the local entities come in under the scanners to remove oil and grease and system. We have a dental program where the dental clinics, what they do, the amalgam which is coming out, that enters the sewer system also. They have to put an amalgam separator. We make sure that dental clinic has an amalgam separator. So there is a one-time authorization. They have to build and have an amalgam separator. The wastewater which is coming out, it should pass through that. It has a good efficiency. We are making sure, we are training the cities, make sure that all the dental clinics are coming under that stand. I monitor all that, and we see that our people monitor them. So they have an responsibility of reporting. They uh, what is it? Quantity is less. See, that is the important. Quantity is less, but if they are carcinogenic, what will happen? 1 ml, 2 ml in the clinic, oils and all they use, if they just leave it, what happens? They are carcinogenic. They will go to through the sewer system. They will enter the treatment system, and you will not be able to remove, because your treatment system doesn't have a capability to remove. That is, tertiary treatment is not just the giving a chlorine dose and discharge. That's why you don't measure. No measurement, no pollution. So that enter the, you are discharging it to the river. What happens? That will enter the, yeah, people who are working in the fish feed somewhere there on the fisheries. I heard somebody was working in the fisheries. Yeah. Oh, yourself. See, they are the people mostly afraid of. See, their job is to protect aquatic life. That enters the food chain. See, I will come to them. Come to some of the pollutants. You you can imagine what is the removal concentration. You see the metal concentration you have seen. How much? It's not much, right? If you say zero point 0.01 milligram, 0.001 milligram is microgram, we will go microgram. Right? Or see some of the standards you see, they are in μg, not mg. 1,000 times less, very less, but still they are there. We go parts per billion. These are some of the pollutants which are coming now. That's why we don't have a proper methodology. We are working. We have a guidance document. Come up and see. There are parts per billion. Yeah, parts per million. Parts per billion. See the PCB and PFAS. You see, they are all in the system. We try to track the sources already there. If it is a point source, industry is the point source, right? Industry is the point source, you can locate. If it is a non-point source, if it is a storm water, if it is entering the environment and water quality river through the storm, non-point source, what you will do? It will all go to the river. If the clinical waste or any toxic waste, just it is thrown outside, where it will end up? Carcinogenic. Even 1 ml, 2 ml. That's why any waste which is coming from uh, the clinics, it has to be incinerated. Highly toxic. So it is not the question how much concentration. It is not like that everything should look big, but minor concentrations are very dangerous. So that is why in the fisheries, what happens? They enter the aquatic system.
Yes, from water, it is by the fishes through gills. They intake the water and which contain the chemicals, and they get stored in the fish muscles.
Ah.
And then when the fishermen do the fishing, and they are used for human consumption, so it reaches human and they are carcinogenic.
This is how. This is how we enter the food chain. If you are just throwing on the soil, and many people on the here on the soil department, you see, enters the food chain through that also. So these are listen. So these are the some of the contaminants or carcinogenic. They you just can't get rid of. However small they are, they enter the food chain. Then in the body, you see the concentrations I had given for earlier. How small it is. It will all end up in the food chain, in the environment. So these are some of the things you will have to take care. However the small the concentration is, you understood the importance of biological system, what are the components in the biological systems, how you will have to take. I told little bit about how to remove the toxic compounds also, how we treat, how we acclimatize, and how we were able to target certain concentration, certain contaminants, pollutant of concern in order to make it safer. So this is about all the biological treatment systems. You have a basic understanding how this biological system works, what is important, how you should take care of the wastewater. All is contained in this lecture. If you have any questions, let me know.
Any question? Any query?
Thank you, sir, for your insights. Sir, I have one question. It's not exactly related to this, but I have one doubt in my mind. Like in India, every year temperature is increasing at very fast rate. Right now in April, we are facing around 40 degrees Celsius in many parts of country, and most of the wastewater treatment plants, mostly industrial plants, are located in the urban areas or areas which have quite high temperature. So is it going to affect the efficiency of the plants due to high temperature, like biological activity will be inhibited, or any this kind of thing we will face right now or in coming years if the temperature goes on increasing like this? And especially where these industrial treatment plants are located in our country are mostly the areas where the temperature is quite high due to urbanization and all. So I have a doubt, is it going to affect these treatments or biological activities which we look upon in the secondary treatments?
Very good. Sit down. Thank you. So bacteria, there are a wide range of bacteria. In a heterogeneous, if you see the bacterial range, there are thermophilic and mesophilic, right? They work at a different temperature. Thermophilic bacteria are even work at a higher temperature. So that is not going to affect. You have also seen there are countries where the temperature goes down. You can also see the treatment plants there. We have a biological system. Where I live, the temperature goes down. Where I lived earlier, temperature goes minus 40. So still we have a biological system. So we have a wide range of bacteria which can survive at different temperatures and take care of organic compounds, take care of the biological treatment, work efficiently in a different temperature zones. We are very smart in taking the advantage of bacteria, right? But we have to do at the same time our responsibility also. That is important. So that is not going to work. That is not going to affect anything. We have technologies. We have the bacteria range also which work at different temperature. Whether it range increases or decreases, we have an source for that, tools for that to make it more efficient. Right?
Sir, I have a question. In our cities, daily use waters, what we actually get from the water sources, they use chlorine, and that chlorine, after using the water, it is being the wastewater. So there is the concentration of chlorine in the wastewater also, in the effluent of the wastewater of the city. So what problem that can cause? And as we know, chlorine is a carcinogen. So
Okay. So not carcinogenic. So what happens is, listen. So in the wastewater, if the effluent is discharged to the river, what we do is we give a very small dose of chlorine, which will be very residual. Earlier we used to do, but now the ultraviolet technology has come. If you know the wastewater is effluent treated wastewater is discharged to the rivers, we use an disinfection, ultraviolet disinfection we use, so there is no chlorine at all. That is, earlier they used to happen, but still that is not a big problem. Many plants still use, the treatment plants use the chlorine. So you give us very small dose of chlorine just to make sure that the bacterial load should not be more at the time of discharge.
water sources, what the water supply of the city, the supply of the city is the water demand, what we use in our household.
Also,
That
drinking water,
yeah, that drinking water contains a
chlorine.
good concentration of chlorine, and that is going to the effluent of the wastewater after being used in the household. So how
No, no, no,
the
no.
activated
Correct.
sludge is
Okay, go ahead.
working?
Okay. So if you are using the drinking water, we try to keep the residual chlorine 0.2, 0.4, 0.5, less than that, so that that is taken care of in the distribution system. But once it is done, it won't be having any chlorine. It is zero chlorine. The wastewater which is coming out of the residence doesn't have any chlorine. It won't be having chlorine at all. So that way it enters the system. But in the drinking water, I agree. Sometime if the chlorine dose is higher, you can immediately feel. In that water, you will have to wait for some time, so it will just goes away and then drink. So that is why it is important when you are putting the chlorine dose, residual chlorine, you will have to be very careful in measuring it. That's why measurement plays an important role. So you should if you put a more chlorine, residual chlorine, that may end up in the drinking water. You immediately, it gives us some kind of a pungent smell. You can notice the chlorine presence. So that is important. So dose is important. By that way, you can reduce it.
Sir, another thing is, what is the source of this activated sludge in a basic, after just setting of the STP. So, what is the primary source of the fast giving activated sludge?
Activated sludge is the biomass. We develop, bacteria are developed, and they are responsible for reducing organic compound into a stable one, right? So bacteria will go on increasing. Bacteria are there everywhere in the sludge. If you analyze back, it is not a big thing. So when we did, so we are treating in a wastewater from the refinery. We brought the waste sludge from the treatment plant, from the refinery, and then we started an experiment. Many people bring the sludge from the domestic wastewater sewage treatment plant and then develop into the system, and then the treatment, biomass is used for the treatment. So bacterial are there in the sludge. It's not a big.
Can we use any modified biomass for refining the oil and greases. Sometimes use some biotechnologically modified organisms to remove the oils. I mean,
You can
petroleum and all.
you can do that. There are the bacteria kind of stuff is available. They use it and put in the water and then they start doing it. So it is available in the market also. They start with that, right? In the septic tank, what you will do when the septic tank is built, we bring a cow dung and put there. Bacteria are already there, right? So bacteria are developed initially and they go on increasing, right? Then the septic system starts. So you can bring a sludge anywhere. The all that is why the heterogeneous bacteria are present. Number of thousand type of different bacteria will be there, and that will be acclimatized according to the type of wastewater. It is not that difficult. Anywhere you can find out.
Sir, actually, I have one question regarding the type of the biological treatment processes. So most of the times, activated sludge process is the most popular and used, and that is the very old technology also. But there are different other things also: membrane bioreactor, RBCs. You have said trickling filters. So industry decided its own what type of the technology they have to use, or there is some guidelines regarding the capacity of the wastewater or like the type of the pollutants.
So
Who
there is
decide that thing, sir? Actually,
correct. So there is no technology like you want to use the best technology. That is why when you do the design, you will find out what are the technologies available according 3-4 technology. You will make a comparison studies and you will say that this is more efficient. Activated sludge processor, stabilization pond, oxidation ponds, right?
yes,
And rotating biological process or trickling filter. You find out all these different methods which is useful, efficient, then you use.
okay. Firstly, there is some
Yeah.
exercise regarding the energy and all these
Yes,
things.
yes. Energy is very important. You that's why you see activated sludge process
That
is
is
the word one where it is easy to operate.
yes, sir.
Just sometime you have to swim against the stream and find out which is the good one, right?
Yes, sir.
So once the system is set, people are more comfortable in using that, right? So there are other technology, biological treatment technologies are there where we use different technologies to treat the waste. I will show you one more case studies what kind of biological system is used. Sometimes not today we are have a visit, probably tomorrow. We use BIDA system
Okay.
to treat the high organic compound and also PCB. That's one example I want to give it to you. I will show you. See what is the different technology. We went against these convention
Traditional,
technology,
yes.
and that has worked very well,
Okay, sir.
right? So there are we put a pilot plant for 3 different biological systems, and then we treated the wastewater coming out of the coal mine, and then we did an analysis which is the best technology we should go for removing selenium, right? Similarly, selenium is one of the component in the coal
Yes, sir.
mine,
Yes.
is it? So then we selected one technology, that is a gating process. That is the expert like you or many people here, you will have to apply which is the best technology, how efficient it is. That is why we do a laboratory study, pilot plant, and then big plant. So
Yes.
this is how it is done, and it is for experts, like you guys to decide which is the best one, not the sum, right? That is how.
Thank you, sir.
Thank you.
Good afternoon, sir. Sir, as you have mentioned the phosphorus removal step,
Yeah.
is there any additional steps industries are taking to remove the phosphorus as it is a limiting factor in fresh water?
Yes, there are many technologies where even in the domestic wastewater removal, where the phosphorus biological processes are there where they can remove phosphorus. But if your effluent has a more phosphorus, you are discharging it to the river, it may give rise to algae, correct? Uh, all right. So if it is so, then the algae growth and all that freshwater will come into areas, right? So there are technology available for those kind of pollutants existing in the waste.
Sir, after the treatment, can we use these treated liquid effluents as a organic liquid fertilizers?
Organic liquid fertilizers, people apply in the sense if large effluent is produced, you can use that as an for the irrigation. Then you will have to have a monitoring of the effluent type of the crop you are growing. Is it how much you are applying? That all is important, right? So it should be contaminant free. It should be work as a nutrient which are present in that nitrate. The wastewater which is treated has a nitrate in it to the certain level can be applied for the land, and the nitrate uptake we study in the crop, and also how much remains in the soil. I have one example case study here. I will mention you. We apply the treated wastewater, industrial wastewater, to the growing grapes. That grapes again is used to make wine. Is it? So then in that case you should have a soil monitoring, should have a crop uptake, how much is taken by the crop and how much is in the soil, which is not creating any issues with the groundwater and the soil, right?
Sir, my question is related to greenhouse gas. So, as we know that wastewater treatment is an energy intensive process, so which directly you can say that it emits CO2 because it comes from coal mostly. And then during the nitrification process, that is during the treatment, biological treatment, nitrification, denitrification, there is emission of nitrous oxide during the process, and also anaerobic, during the anaerobic process there is methane emissions, so which are two important greenhouse gases. So how significant is greenhouse gas emissions when it comes to wastewater treatment?
Yeah, we have there is a greenhouse gas emission also. Uh, Greenhouse gas emissions is the carbon inventory. We study carbon footprint, right? So it depends upon, in the wastewater also produce certain greenhouse gas, right? So we quantify that how much is the contribution greenhouse gases are produced, and that is inevitable. Greenhouse gas is another level of work. We can also discuss more about that. Uh, we have a lot of work has been done in the greenhouse gases, right?
Okay, so sir, do the industry are they also concerned about the this greenhouse part or not?
They are concerned like water. I will take 2 3 minutes. So you see how the water use has come. Similarly, a greenhouse gas emission quantification is there for the industry. Each industry have to quantify, that is called a carbon tax. Is it? Carbon tax, they have, if they are producing this much greenhouse gas, then they have to pay. So to go in little bit more, I worked in the industry. I was worked with the state government, federal government, and in when I was in Canada, to develop the baseline study for a greenhouse gas. What we did is, each coal mine, how much greenhouse gas it contributes. Accordingly, government put a tax per ton. You will have to pay $15, right? So they gave 100 ton free in the beginning. Then for every above 100 you have to pay. So they started collecting millions of dollars, and today also it is going on. So each industry, how you do the income tax, in the similar way, industry has to do a carbon audit, right? So they do how much carbon they are contributing, and accordingly they will have to do. We started in 2010. It started in Canada. I was working at that time in the Canada for a coal industry. We worked with the state government and federal government in developing the baseline study. And for 3 years back, we will go and develop the baseline study. What was the greenhouse gas produced this year, this year, this year? That is taken as a base, and then above that 100 they will have to pay money. That way they collected billions of dollars, millions of dollars, and then it is regulated. In the greenhouse gas, there are a coal mine which produces, there is an emission factor, how much you are producing the coal. Based on that, it is converted into the greenhouse gas, carbon footprint, and they will have to. So that is also coming up next stage. It is already there in other countries. We do regular basis. Oh, I can tell you more detail about that, how we developed a greenhouse gas baseline study, how we did the carbon uh, calculations. You can also go back. We developed a system. If you put the production, you will find out how much is the greenhouse gas produced per day. So that is the system.
Good afternoon, sir.
Okay.
Sir, as I'm from agribusiness management background, so my question is, my interest always comes into the collaboration and partnership. So
Okay.
yesterday we had a lecture on lecture number 4, small and medium industries. So what is the scope of public and private partnership? Like in India, we have a Namami Gange that launched under the Ministry of Jal Shakti in 2014. So what are the initiate? Is there any scope for the public and partnership?
Yes, in today's world, there is a large scope for a public partnership, public and government sponsored.
Public and private.
Yeah, that is how the most of the roads and infrastructures are developed. Private companies, they put money and invest. They collect the tolls, and after 20 years, it can be made free. That is how it is done. That is a very uh, build, operate, and transfer. You will build the system, operate it for certain years, and you will also take a lot of incentives for that, and then transfer to the government. So that system is working very well. It is not necessary that everything has to be done by the government, right? Many public partnership is going in a very wide way, and it is most popular today. Yeah, especially in India, a lot of work is going on, and a lot of roads, tunnels. Yeah, in UK, you will also find big sewage treatment plants are built and operated by a private people. We have that system already in United States. They build a big treatment plant system, and they accept wastewater from different industry. They charge them. This is the cost. We'll treat and we'll take care of wastewater. That is already there.
So, sir, what are the initiative taken by the already taken by the USA? Any example?
There are
So that
many. There is that in the cities where I go. That is why I said this is the publicly owned treatment plants. This is also, there are cities where industries or group of people will come together and build a treatment plant. We have also given authorization. They can collect
yeah, that authorization.
based on the volume of the wastewater. They can, just like an industry they do. Yeah, there are many. There are many like that. It is
Thank you,
not
sir.
necessary. It is
Thank you.
should be done by the government. Very good.
Thank
I
you, sir.
think you don't have questions.
Yeah,
Well,
we
let's
have to
do
stop
that.
this.
But don't forget to write a half page about yourself, what you learned, right?
So next day, come with that note. Okay. So bus is waiting for you, and you should go and take a